All right, ready to dive into some Linux.
Let's do it.
Today, we're going deep on some Linux essentials. We've got this collection of classic Linux interview questions, and, well, we're going to unpack them all.
That sounds like fun.
So whether someone's, prepping for a tech interview or just wants to brush up on their Linux skills, or maybe they're just curious about this operating system that, pretty much powers a lot of our digital world.
It really does.
This deep dive is for them.
Yeah, it's amazing how many seemingly simple Linux concepts can really trip people up in, like an interview.
Oh, yeah.
If you understand the why behind the commands,
Yay.
that can really set you apart.
Exactly. It's not just about, memorizing a bunch of commands.
Right.
It's about showing that you understand how Linux works.
It's exactly.
At a deeper level, right?
Yeah.
So let's start with the basics, like navigating the system. Imagine you're, suddenly given a Linux server and you need to figure out, what are you even dealing with here? What is this thing?
Right. That's where knowing commands like, host name, unnamed,
Right.
those come in handy.
Okay.
Host name will tell you, obviously,
Yeah.
the system's name.
Okay.
Unnamed, that'll give you the kernel version, and other system information.
Okay.
It's kind of like gathering intel before you actually start, working on the server.
Right. So it's like checking the system's ID card, basically.
Exactly, yeah.
But what about performance? How can we quickly assess if this system is, healthy and running the way it should?
Well, that's where top and uptime come in handy.
Okay.
Top, that gives you a real-time look at system performance. CPU usage, memory consumption, all that good stuff.
Okay.
That's your go-to for identifying resource-hungry processes, potential bottlenecks.
Right. So if I'm in an interview and they're like, how would you troubleshoot performance issues? I should just say top.
Top would be a good place to start.
Okay, good.
Shows how to monitor those system vitals. And then uptime kind of goes along with that.
Yeah.
Uptime will tell you how long the system has been running and the average system load.
Okay.
So if you see a really high load average, that could indicate some potential problems.
Right. So it's kind of like checking the system's pulse. All right. So now let's move on to files and permissions.
Okay.
It's like we're going, deeper into the inner workings of our Linux machine.
Exactly. And just like, secure facility, not everyone has access to everything. Right? Same thing in Linux.
Mm-hmm.
Access and security are managed through files and permissions.
Okay. So one of those crucial files is etc. on food, right?
Sure.
Could you break down for us what makes that file so important?
Yeah, so etc., it's like a directory. It lists essential information about every user on the system. Username, UID, GID, home directory, even their default shell.
Wait, hold on. UID and GID, now those sound familiar, but can you remind me what those stand for again?
Of course. UID, that's user ID, and GID, that's group ID. And those are numerical identifiers that Linux uses to manage users and groups. It's like having different levels of security clearance, within an organization.
Oh, okay. So, different users might have different levels of access based on their UID and GID?
Exactly.
But what about their passwords? Are those stored right there in etc. pass?
Ah, that's where it gets interesting. So if you look at etc. pass, you'll often see an X in the password field.
Okay.
Now, that doesn't mean there's no password.
Mm-hmm.
It just means that the actual, encrypted password is stored somewhere else more secure.
Oh, okay.
It's tucked away in etc. shadow.
Ah, so it's like a hidden vault for the most sensitive information.
Exactly.
But why is that separation necessary?
Security.
Right.
Etc. shadow is much more restricted, only accessible by, privileged users. So that adds another layer of protection, making it much harder for, unauthorized users to get to those passwords.
That's a clever security measure. It really highlights how seriously Linux takes security.
Yeah, it does.
Speaking of hidden things,
Yeah?
I've always been curious about hidden files in Linux.
Oh, yeah.
Are they secret compartments within the system?
You could say that.
Yeah.
So in Linux, any file or directory name that starts with a dot,
Okay.
that's considered hidden. So in a normal directory listing, you won't see them.
Right. But there's got to be a way to reveal these hidden gems, right?
There is. The Ulzla command.
Okay.
That's your key. It'll list all the files, including the hidden ones, along with permissions and other details. It's like using, a special lens to see things that are normally invisible.
I see. It's like knowing the secret knock to get into a hidden room. Okay, so we've explored users, files, even hidden secrets.
Mm-hmm.
Now let's dive into what makes a Linux system tick. Processes and services.
Okay.
This is where we see Linux in action, right?
Right. So, every task, every action you do, that's a process in Linux. That's how the system gets things done.
And to see all those processes in action, we use the peeps command.
Exactly. It's like looking at a snapshot of all the activity happening within the system at any given moment.
Okay.
Now, within those processes, we have these special ones called services.
Okay, what makes services different from regular processes?
So think of services as kind of like essential background tasks that keep the system running smoothly. So things like network connectivity, printing, web servers.
Right.
These are all handled by services.
Okay.
They kind of work behind the scenes, providing functionality to other programs or users.
So processes are individual actions, and services are more like those ongoing systems that support everything else.
Exactly.
Okay.
Yeah.
But how do we manage these services? Can we control them?
Yeah.
Like start them, stop them when we need to?
Absolutely. Linux has tools for that. So System Teal, that's the modern way to manage services.
Okay.
You can start, stop, restart, check the status of the service.
Okay.
And then there's the older service command, which still works on many systems.
So both of those give us control over those essential background tasks. This is making me realize how much we rely on services without even realizing it.
It's true. They're kind of the unsung heroes of a Linux system.
They are. They are. All right, so we've talked about processes, services. Let's shift gears a little bit and talk about networking.
Okay.
It's like the lifeline of our Linux system, right?
It is.
Connecting it to the rest of the world. What are some of those essential networking commands we should know?
Well, ping, that's your trusty tool for checking if another machine on the network is reachable.
Right.
You're basically sending out a signal and seeing if you get a response back.
Okay.
And then there's FTP, which lets you transfer files between systems using the file transfer protocol.
So ping is like a quick check for connectivity.
Exactly.
And FTP is our file transporter. But what about monitoring all the traffic going in and out of our system?
For that, we've got netstat.
Okay.
That gives you all sorts of detailed information about network connections, routing tables, all that good stuff.
So it's like having a map of all the data flowing through our network.
Pretty much.
I'm starting to feel like a network administrator already. But before we go too far, let's define some of those basic network types.
Okay.
Because I always get confused between LANs, MANs, and WANs.
Oh, yeah.
Can you break down the differences for me?
Of course. It is easy to get those mixed up.
Yeah.
Think of it like this. A LAN, or local area network, that's a network that's confined to a small area, like your home or office.
Okay.
A MAN, a metropolitan area network, covers a larger area,
Like a city.
like a city or campus.
Got it.
And then a WAN, a wide area network that spans, a vast geographical area connecting multiple LANs and MANs.
Okay, so our system is part of a LAN,
Right.
which might be part of a larger MAN.
Right.
And it's all connected to the massive WAN that is the internet.
Exactly.
That helps clear things up. So within these networks, we need a way to address devices, right?
Absolutely. And that's where IP addresses come in. They're like unique identifiers for every device on the network
Right.
that allows them to communicate with each other.
And I know there are two main types, static and DHCP.
Yeah.
What's the difference between those?
So with a static IP address, you manually assign an address to a device,
Okay.
and it never changes.
Right.
This is best for devices that need a consistent, predictable address like servers.
Okay.
DHCP, on the other hand, automatically assigns IP addresses.
So it's more convenient for devices that move around a lot.
Exactly. Or devices that don't need a permanent address.
So static IP addresses are like having a dedicated phone number.
Yeah,
And DHCP is like using caller ID.
pretty much.
Okay, that makes sense. We've covered a lot of ground with networking. I think it's time to explore the world of scheduling and automation.
Okay.
This is where we can make Linux work for us even when we're not at the keyboard.
Right, exactly. It's like setting up automated tasks to handle all those routine operations.
I've heard of cron jobs, but I've always been a bit intimidated by them. Can you break them down for me?
Cron tab is this powerful tool for scheduling tasks that need to be performed repeatedly. So let's say you need to back up your data every night at, 2:00 a.m.
Right.
A cron job can handle that for you automatically.
So it's like setting an alarm clock for the system to do certain things.
Exactly.
But the syntax for setting up cron jobs always seemed a bit cryptic to me.
it can be, yeah.
Can you give me an example?
Yeah, so a cron job entry, it has 5 fields. And then after that, the command you want to execute.
Okay.
And those fields represent minute, hour, day of the month, and day of the week.
Okay.
So let's say you want to run a script every Monday at 8 a.m. Your cron tab entry would look something like this: 88 one path to your script.
So the 0 represents the 3rd minute.
Right.
The 8 is for 8:0 a.m. The asterisks mean for the day, the month, and month.
Yep.
And then the one represents Monday. It's
Exactly.
like a time code for the system.
Pretty much.
Okay.
Now, along with cron tab, we have the at command.
Okay.
And that's used for scheduling those one-time tasks.
Okay.
It's like setting a reminder to do something specific at a particular time.
So cron tab for recurring tasks.
Right.
And at for one-time events.
Exactly.
That's pretty useful. Any final tips or words of caution when it comes to scheduling and automation?
Yeah, always double-check your syntax. A small error in a cron job could have some unintended consequences.
Right.
Always test your commands thoroughly before, setting them loose on your system.
Great advice. So we've navigated files and permissions, explored the realm of processes and services, and even mastered the art of scheduling.
Yeah.
I feel like we're really building up a solid foundation of Linux knowledge here.
You are.
But what happens when things go wrong? Well, that's what we'll delve into next. Troubleshooting and essential Linux tips.
Sounds good. Okay, so now we're going to move on to an area that I think can seem a little intimidating to some people.
Yeah.
But it's actually really empowering. Troubleshooting.
Troubleshooting.
Even in a well-managed Linux system, things can go wrong.
That's right. It's like that saying, anything that can go wrong will go wrong.
Exactly.
But the good news is Linux gives you a ton of tools and information to help you diagnose and fix those problems.
Absolutely. It's all about knowing where to look and what to do.
Right.
One of the first things I reach for when I'm troubleshooting is DMESC.
Okay.
It displays the system message buffer,
Okay.
which logs messages from the kernel, during boot and just system operation.
So it's like the system's internal logbook, basically.
Pretty much, yeah.
Recording events, potential hiccups.
Yeah, so if you're seeing, some odd behavior, DMESC can often give you clues about what's happening under the hood.
That's a great starting point. Now let's say our system starts running slowly. What are some of the tools we can use to identify the culprit behind these performance problems?
Well, we already talked about top, which is excellent for real-time monitoring. You can see, which processes are using the most CPU, the most memory.
Right. So if we see one process hogging all the resources, we've probably found our bottleneck.
Exactly.
But what if the issue seems to be related to disk performance? Are there tools that can help us investigate that?
There is. IOStat can be your best friend in those situations.
Okay.
It shows you how busy your disks are.
Mm-hmm.
So you can identify any bottlenecks or, potential storage issues.
So it's like checking if the system's hard drive is overloaded with work.
Pretty much, yeah.
Okay. What about hardware problems? How do we troubleshoot those?
Well, that's where dmind code comes in handy.
Okay.
This command will fetch detailed hardware information from the system's DMI table. Think of it as like a really comprehensive hardware inventory.
Okay, so dmind code is like having a blueprint of our system's hardware.
Exactly.
That could be really helpful for diagnosing hardware issues. But let's get a little practical here. Imagine a server is completely down. What are the initial steps we should take to troubleshoot this critical situation?
Oh, that's a great question. This is where having a systematic approach is really important.
Okay.
First, don't overlook the obvious. Check the physical system.
Oh, right.
Make sure it's powered on, all the cables are connected, there are no apparent hardware issues. Sometimes the simplest solution is the right one.
Right. Always rule out the basics first. But let's say everything seems fine physically. What's next?
Next, see if you can access the service console. That can give you direct access even if the network is down.
Okay.
If that's not possible, try a ping test from another machine on the network.
Okay.
If the ping is successful, at least you know the network connection is okay and the problem's within the server itself.
So it's about isolating the problem. Is it a network issue or is it something within the server itself?
Exactly. And if all else fails,
Yeah.
sometimes a reboot can work wonders.
Uh-huh.
If that doesn't solve it, booting from a rescue disk or live CD can be your next step. That allows you to run diagnostics and potentially repair the system.
Okay, that's a pretty solid troubleshooting checklist for a server outage. It's reassuring to know that there are steps we can take to get things back on track. Any other troubleshooting wisdom you want to share before we move on?
Top can be really helpful,
Yeah.
even beyond those initial performance checks.
Oh, okay.
When you're in the middle of troubleshooting, you can use top to see the impact of your actions
Right.
and really help you narrow down the source of the problem.
So it's a tool that keeps on giving.
It is.
Now, let's shift our focus to the heart of Linux, the command line.
Okay.
It's such a powerful interface, but it can seem a little daunting to newcomers.
Oh yeah, it can be.
Let's demystify working with the terminal.
All right. So the terminal, that's your direct line to the Linux operating system.
Okay.
Mastering it opens up a world of possibilities.
I've always been curious about the Vi editor.
So yeah,
It seems like such a legendary tool among Linux users,
it is.
but also a bit intimidating, you know?
Yeah, it can be.
What makes Vi so special, and how do I even begin to use it?
So Vi is a powerful text editor that's always available right there on the terminal. It might seem a little cryptic at first,
Yeah.
but once you grasp the basics, its efficiency and speed become really apparent.
Okay.
The key is understanding that Vi operates in different modes.
Modes. Could you explain that
Yeah.
further?
Yeah, so there's command mode where you navigate text, delete lines, copy and paste.
Okay.
And then there's insert mode where you actually type in the text.
So it's like switching gears in a car.
Yeah.
Each mode has its own function. How do I move between these modes?
Pressing Ingir's insert mode, and then incase takes you back to command mode.
Okay.
Once you're comfortable with that, you can start learning basic commands.
So I for insert,
Yeah.
S for escape. I can remember that.
Yeah.
What about essential actions like deleting a line or saving a file?
So to delete a line in command mode, just press D a D.
Okay.
To save and exit, you type .wq and press enter.
Okay, so DIIO to delete, .wq to write and quit. Those are handy shortcuts. But VRI has a whole universe of commands, right? Where can I go to learn more?
Absolutely. There are tons of resources online and built into Linux itself. The man command, short for manual, is your best friend.
Right.
Typing man-vi in the terminal will bring up the complete manual for Vi.
That's a great tip. I often forget about the man pages. Now, beyond Vi, are there other terminal tricks that can make us more efficient Linux users?
Definitely. Terminal control keys.
Okay.
Those are essential shortcuts. So Ctrl plus C interrupts a running process.
Okay.
It's like hitting the emergency stop button.
Right.
Stu plus D signals the end of input, often used to close a terminal session.
So Ctrl plus C stops a runaway process. Ctrl plus D is like saying, I'm done here. What other control keys should I know?
Ctrl plus Z suspends a process.
Yeah.
It puts it on hold.
Okay.
You can resume it later with the FG command. These control keys give you much more control over your terminal
Right.
and can be real time savers.
Those are great. They seem straightforward once you know them, but I bet they make a big difference in your daily use.
Oh, yeah, they do.
Now, speaking of efficiency, tell me more about aliases. I've heard of them, but I'm not quite sure how they work or why they're useful.
So aliases are like nicknames for commands.
Okay.
So let's say you frequently use a long command like LD to list all files.
Right.
You can create an alias, maybe just oli, to execute that same command.
So instead of typing out that whole command, I can just use a shortcut.
Exactly.
That seems incredibly helpful, especially for those commands that you use all the time. Are there any limitations to what I can alias?
No, not really.
Wow.
You can alias pretty much any command or sequence of commands.
Wow.
It's a great way to really customize your terminal experience,
Okay.
boost your productivity.
I'm starting to see the power of aliases. It's about making the terminal work the way you want it to.
Exactly.
Now let's move on to another crucial aspect of Linux, package management. This is how we install, update, and manage software on our system.
Right. Package management is a key strength of Linux.
Okay.
It simplifies software management and ensures that all those dependencies are handled correctly.
Okay. Now, I know there are different package managers for different Linux distributions. Can we focus on Yum for now, which is commonly used on Red Hat-based systems?
Yeah, of course. Yum is a powerful package manager that makes installing and removing software a breeze.
Okay.
So to install a package, you just use the command yum install package name.
Okay.
For instance, yum install HTTPD would install the Apache web server.
And to remove a package, it's just yum remove package name.
Exactly. Very intuitive. One of the best things about package managers like Yum is that they automatically handle dependencies for you.
Right.
That means you don't have to manually install each and every prerequisite package.
That's a huge time saver.
Yeah,
It also reduces the chances of running into compatibility issues, right?
absolutely.
But why is package management so important in the grand scheme of Linux?
Well, it ensures a consistent and reliable way to manage software,
Okay.
which contributes to the stability and security of the system.
Right.
Plus, it makes it incredibly easy to keep your system up to date.
So it's not just about convenience, it's about good system hygiene.
Exactly, yeah.
Any final words of wisdom regarding package management before we wrap up this section?
Yeah, regularly update your system using Yum Update. This ensures that you have the latest security patches and bug fixes.
Okay.
Think of it as like giving your system a health check.
Right.
Keep it in tip-top shape.
Yum update. Got it. So we've covered a lot in this section, from troubleshooting techniques to command line mastery and package management. I feel like we've really leveled up our Linux knowledge.
You have. You're well on your way to becoming a confident Linux
Or
user.
I hope so.
But we're not done yet. There's still more to explore in this vast and fascinating operating system.
Welcome back. We've really journeyed through like the ins and outs of Linux,
We have.
from navigating the file system
Mm.
to troubleshooting those server meltdowns.
Right.
But like with any deep dive, there's always more to explore.
There is. Even just focusing on those interview-relevant skills, I feel like we've just scratched the surface of what makes Linux so powerful.
Right. And I think one of the things that makes Linux so unique is its open source nature.
Absolutely.
It's a collaborative effort,
Mhm.
constantly evolving thanks to this global community of developers and users.
Yeah, and that collaborative spirit really extends to the resources that are available for learning Linux.
Right.
Online forums, documentation, tutorials,
Mhm.
you name it. There's a community out there ready to help.
So it's like having this global network of Linux experts at your fingertips.
Pretty much.
That's pretty incredible. As we wrap up this deep dive, what stands out to you as the most important takeaway for our listeners? What's the one key concept they should walk away with?
I think for me, it's understanding the power and flexibility of the command line. Yes, Linux has graphical interfaces, but the terminal is where you truly unlock the system's potential.
Mm.
Once you grasp those core commands, and concepts,
Mhm.
you can do pretty much anything from the command line,
Right.
and often more efficiently than you can through a GUI.
I completely agree. It's like speaking the language of the operating system. It might seem daunting at first, but it's incredibly rewarding.
No, yeah, it is.
So, okay, as we conclude this exploration of Linux essentials, let's leave our listeners with a thought-provoking question.
Okay.
We've talked about Linux's current strengths, but what about its future? What role do you see Linux playing in this, constantly evolving technological landscape?
That's a great question.
Yeah.
I think Linux is really poised to play an even bigger role in the future.
Okay.
It's already the dominant operating system in servers, in cloud computing, and in embedded systems.
All right.
As we move towards a more interconnected world
Right.
with the Internet of Things,
Mm-hmm.
I think Linux will be at the forefront, powering everything from smart devices to self-driving cars.
That makes a lot of sense. Its adaptability and open source nature make it perfectly suited for these new and emerging technologies. It's exciting to think about the possibilities.
It is, it is.
Well, for those who are eager to continue their Linux journey,
Yeah,
remember there's a whole world of resources out there just waiting to be explored.
absolutely. Online tutorials, community forums, open source projects. There's really no shortage of ways to learn more.
Keep experimenting, keep learning, and most importantly, keep that spirit of curiosity alive.
Couldn't have said it better myself.
Thanks for joining us on this deep dive into Linux essentials.
It's been a pleasure.
We hope you've gained some valuable insights that will serve you well, whether you're, prepping for that big interview or simply expanding your understanding of this amazing operating system.
Absolutely.
Until next time, keep exploring the world of Linux.